In this video, we're going to go over a few applications of the concepts of torque. First, let's talk about wheeled locomotion. Specifically, we're going to talk about either cycling or using a wheelchair. If we were to create an H model dealing with performance of the device, either the chair or the bike, we can talk about having a linear velocity of the wheel. As you recall, the linear velocity of the wheel is going to be determined by the radius of the wheel and then the angular velocity of the wheel. That angular velocity of the wheel is going to be determined by the angular acceleration of the wheel and the change in time. The angular acceleration of the wheel is going to be determined by the torque of the wheel as well as the moment of inertia of that wheel. Now this H model will apply for whether or not we're talking about the bike or we're talking about the wheelchair. However, the application of torque will be different for both the bike as well as the wheelchair. Let's tackle the wheelchair first. On a wheelchair, we're going to have the wheel, and then we're going to have the hand rim. Now, the hand rim has to have a smaller diameter than the wheel. Otherwise, you'd be riding on the hand rim rather than on the wheel itself. The hand applies a force to the hand rim. That force can be broken down into both a normal as well as a tangential force. That normal force is going to go parallel to the spokes or perpendicular to the wheel, and the tangential force is going to go parallel to the wheel or perpendicular to the spoke. That tangential force on the hand is the hand that's going to create torque on the wheel that is going to cause the wheel to rotate. So for our H model for the wheelchair, we'll see the torque of the wheel is going to be determined by the perpendicular force of the hand as well as the radius of the hand rim. Now let's take a look at a bicycle. For this lesson, we are going to ignore the gearing that's used on a bike. We have the rear wheel of the bicycle, and then welded to the rear wheel of the bike, we have the sprocket. The chain attaches to the sprocket on one end and the chain ring on the other. The chain ring is going to then be welded to the crank mechanism that includes the pedals. The force on the chain is what creates the torque about the rear wheel, which causes it to move. That force on the chain is created by the torque that's placed on the chain ring. The torque on the chain ring is going to be determined by the force that's going to be placed on the pedal. The force that's being placed on the pedal is going to be determined by that force of the foot. And again, only the perpendicular component of that force produces torque, so we have to look at the perpendicular component of the force provided by the foot. So if we look at an H model now for bicycles, we will see the torque of the wheel is determined by the radius of the sprocket and the force of the chain. The force of the chain is determined by the torque on the chain ring. The torque on the chain ring is then going to be determined by the perpendicular component of the force of the foot as well as the radius of the crank. I'd also like to take a minute to talk about resistance exercises. First, let's consider pulleys on the right-hand side. A pulley, or at least a single pulley, is not going to create a mechanical advantage. The only thing a pulley is going to do is change the direction of a force vector. However, if we apply two or more pulleys to a system, then we can create a mechanical advantage. We're not really going to talk about that in this class. Then let's take a look at machines. First, we can say that a machine should be aligned where the axis of rotation of the machine is aligned with the axis of rotation of the joint. That's clearly not the case in our picture, and our personal trainer needs to do better. Second, we can say that wherever the roller pad is going to be placed, that's going to create a force that needs to be overcome. Notice, again, that our personal trainer is kind of falling down on the job. She has that roller pad almost all the way up at his tibial tuberosities. Unless he has some sort of injury that he's rehabilitating from, he should probably have that roller pad all the way down by where his malleoli are. That will create greater resistance that he has to overcome while he's performing this exercise. So again, a couple key things to understand about resistance exercise are, number one, that a pulley will not create a mechanical advantage in and of itself, but a system of pulleys will. And number two, when we're looking at a resistance exercise machine, We want to align the axis of rotation of that machine to the axis of rotation of the joint. And if we want to maximize the resistance provided by that machine, we want to place the resistance pad as far away from that axis of rotation as is comfortably possible. And that's just a few applications we have of torque.